So for Unit 2 for HESI Chemistry, I've got a mix of 7 videos that I found on YouTube that cover all the topics that you need to know. So this is the only one that I'm making myself, and it is basically just a review of the YouTube videos in the playlist and emphasizing the most important things that you need to make sure you know, understand, and remember from those videos. So the first one is about the difference between compounds and mixtures. You need to know that a compound cannot be broken down or separated physically, but only chemically changed. And a mixture, on the other hand, can be separated physically. So examples of that, compounds are things that have a chemical formula, such as NaCl or H2O, and a mixture has 2 or more chemical formulas together, such as sodium chloride and water mixed together to form salt water. And it may not have come up in any of the other videos, but another vocab word you need to know is that a solution is a type of mixture. It's when one chemical is dissolved in another, such as when salt is dissolved in water. And you need to know that a solute is the thing being dissolved, and a solvent is the thing doing the dissolving. So in this case, the salt is the solute because it's being dissolved in water, and the water is the liquid that is doing the act of dissolving. For the second, third, and fourth videos, there are 3 different videos about ionic versus covalent bonds. So most important things you need to know from those are electrostatic attraction is the name of the force that holds any positive and negatively charged particles together. And that's the force that holds, for example, positively charged sodium and negatively charged chlorine ions together in sodium chloride, which is an example of an ionic bond. Ionic bonds themselves are always formed from a metal and a nonmetal. And so if you're looking at a compound, all you have to look at is the first element in the formula. If it's a metal, then it's an ionic bond. If it's a nonmetal, it's a covalent bond, because a covalent bond is 2 nonmetals bonded together. So if the first element is a nonmetal, it's covalent. If the first element is a metal, it's ionic. Nonmetals, this is a list of the most common nonmetals. There's so many metals it would be ridiculous to try to learn them. So the easier approach, I'm going to give you an alternative to this, but one approach is try and memorize the nonmetals. You don't need to be able to rattle off the list of them, but if you saw any of them, you should be able to recognize, like if you see nitrogen, which is an N, you should be able to recognize that that's a nonmetal, so that if it's the first element in a compound, you know that it's covalent. These are the most common nonmetals, and a way that some people learn them is this sort of made-up word CHOMPS, CHONPS. Then you'd have to also remember fluorine, which is F, and chlorine, which is Cl. But also, most of the time, nonmetals are represented by a single letter. The exceptions to that are chlorine, bromine, and selenium, and bromine and selenium are not really that common. So if you remember single letter and just remember chlorine as an exception, you're in good shape. Most metals are represented by 2 letters, like Fe for iron and Ni for nickel. And the only common exception to that is K, which is potassium. There are a few others, but they're elements that almost never come up at this level. So just remember that K is a metal. All the other metals that you're going to come across are represented by 2-letter abbreviations. Single letter abbreviations are generally nonmetals, and the most important exception to that is chlorine. Video 5 is about intermolecular forces. Most important thing to remember from that is that the weakest of the intermolecular forces is called dispersion forces. The strongest is called hydrogen bonds. The middle is dipole forces, but that's a lot less important to remember because generally what you're going to be asked about that is which is the weakest of the intermolecular forces, dispersion forces, or which is the strongest of the intermolecular forces, hydrogen bonds. And you will probably have 1 molar mass calculation. So make sure you get some practice for doing that. Here is an example, and since you don't have a periodic table, in the video it says look on the periodic table and tells you where to find the atomic mass of each element, but you won't need to do that. You don't have a periodic table, but in the question they're going to tell you the molar mass of each element that's part of the compound. So an example here is what is the molar mass of ethanol. They'll tell you the molar masses of the elements that are in it, carbon, hydrogen, and oxygen. They might give it to you out to more decimal places. If they do, use those. I'm just making it fairly simple here in this example. So as it shows you in the video, for each element that's in it, you're going to take the mass of that element times its subscript, and then you're going to add the mass of the next element times its subscript, and so on until you get through all the elements in the compound. So for C2H5OH, we're going to take 12, which is the mass of carbon, times 2. And then we're going to add 1, which is the mass of hydrogen, times 5, the subscript that's after 5. 16, which is the mass of oxygen. If there's no subscript there, that means it's an implied subscript of 1. So 16 times 1, and then 1 for this additional hydrogen here, and then times 1 because there's 1 of them. You're going to do all your multiplication first, and then your addition, and you get a total of 46 grams per mole for this compound. So practice some of those and make sure you're comfortable with doing that calculation. The last video, video 7, is asking you, is showing you how to write the formula for a compound if you're given its name. And I've got a couple examples here, and I picked these because these are ones that people have seen on previous HESI tests. So the first example is copper 1 cyanide, and the second example is copper 2 cyanide. And the first thing I'm going to tell you is the trap to not fall into. A lot of people look at this and think this means 1 copper and 1 cyanide, and then they look at this and think it means 2 coppers and 1 cyanide. But that is not what the Roman numerals mean. They mean the charge, and then the charges have to be balanced within the compound, so this is the process you have to go through. First, you say copper 1. The Roman numeral 1 means it's copper, which is Cu, with a +1 charge. Cyanide is Cn, it's a polyatomic, and it has a -1 charge. That's something that you would just have to know, but I'll be giving you a list of some polyatomics to remember and what their charges are. There are only a handful of common ones that you really need to know. So if you put them together, you've got copper +1 and cyanide -1. If you do the crisscross, you bring this one over to the copper and this one over to the cyanide. So you've got Cu1, Cn1. Subscripts of 1, you don't actually write them in, and in this case we don't need the parentheses because there's only 1 of them. So this becomes CuCN. And that happens to be the same as what I was saying not to do, which is 1 copper and 1 cyanide. Just by coincidence, this one works out that way, but you'll see here this second one does not. So copper 2 means copper with a +2 charge, and cyanide again, because cyanide is always -1. So then you've got the Cu +2 with the Cn -1. When you do the crisscross, you bring the 1 from the cyanide, it becomes the subscript on the copper, and the 2 from the copper becomes the subscript on the cyanide. The subscript of 1 here is not needed. Now we do need the parentheses because we've got 2 of this whole Cn grouped together, so the parentheses indicate that the 2 goes to both the C and the N, and the compound ends up being CuCN2. So not the formula that you would use if you if you looked at the 2 there and you thought that meant there were 2 coppers, that would give you Cu2Cn. So that is what you need to remember to not do. You have to go through this whole process with the charge and the crisscross and end up with the final formula here. So to get some additional practice on doing the formulas from the name, I'm going to put this link. I'm going to send you this document, but this link is also going to be in the YouTube video, and that will take you to this page, which is a practice making compounds. So here we've got sodium chloride, and then we have to pick the ions from down here. So we've got sodium and we've got chloride. And then what you do is you drag them together. The triangle on the sodium is because it's a +1 charge, and then the inverse triangle on the chlorine is the -1 charge, so it's showing how they fit together. So to get them to fit together, you drag them on top of each other, and then they go together like that, and you say done, and it gives you the full formula, which is NaCl. Because it was a +1 and a -1, we just needed one of each. And so then I'm going to go through a few more of these. Sodium oxide. Now oxide, because the -2, it has 2 of these triangles. So you can visually see why you need 2 sodiums that are each +1 to pair up with the oxygen. So this would be Na2O. And they tell you that when you click done. Sodium hydroxide is also just going to be one of each. And aluminum phosphate. Now we've got aluminum with a +3 charge, so it's giving us 3 triangles, and phosphate with -3 charge, and so those, one of each, they fit together just like the sodium chloride did, and that's because they have the same but opposite charges on them. But in the case of aluminum oxide, you've got aluminum with the +3 and oxygen with the +2, and so when we put them together, then we've got an extra +1 here. The only thing we can use to cancel it out is another oxygen. So we do that, and then we've got another spare, and it feels like we're going to be going on doing this forever, but we won't. So then we've got that, and now we've got just enough for that last oxygen to work. So look at this real quick. We've got 2 aluminums and 3 oxygens, and if we had written this out with the aluminum +3 and the O -2 and then done the crisscross, we would have ended up with Al2O3, and that's exactly what we have here. 2 aluminums and 3 oxygens, and that's what you do to get the charges to balance. The other good thing to practice here is to remember that the 2 in Roman numerals is means that it's a +2 charge. So iron 2 is iron with a 2+ charge. It doesn't necessarily mean you're going to have 2 irons. And then oxide is the -2, so in this case, 1 of each. So FeO in that case. And iron 3 oxide, you'd have to start with the Fe with the 3+, so it's got the 3 triangles on it to indicate the +3 charge. Oxygen always has a -2 charge. So again, this is going to be like the previous one where we ended up having to keep adding more until all the plus and minus charges get used up. And which we have here. So again, if we had started with Fe3+ and O2- and done the crisscross, we'd have Fe2O3, which is exactly what we have here. So give some of these a try and make sure you're comfortable going from the name to the formula of the compound.